Picture this. You're operating in a hazardous environment. Maybe you're fighting a fire, or maybe you're dealing with a nasty toxic spill. In that moment, your self-contained breathing apparatus, your SCBA, is quite literally your lifeline. I mean, it's hands down the most important piece of life-saving equipment you carry. But here's the thing, just having air strapped to your back, that's not enough. You need to know exactly how long that air is actually going to last. Miscalculating your time out there can be a fatal mistake. So welcome to this explainer. Today, we're going to completely demystify SCBA air duration math, step by step, so you never ever find yourself guessing how much air you have left in the tank. Okay, here's our mission prep for today. 1, we'll cover the SCBA cylinder basics. 2, we'll calculate step 1, total volume. 3, step 2, total duration. 4, step 3, working duration. And finally, 5, calculating on the run. All right. Let's jump right into part 1, the SCBA cylinder basics. Before we do any actual math, we've got to gather our starting data straight from the physical cylinder itself. If you pick up any SCBA cylinder and look at the label, you're hunting for 2 foundational numbers. First up is the water capacity, or WC. This tells us the actual internal size of the cylinder. It's usually written in liters, something like 6.8 L, or maybe NWC 6.8. Now, if you see it written in kilograms, don't panic. Just remember this really handy fact. 1 liter of water is exactly 1 kilogram, so the numbers translate directly. The second crucial anchor you need is your working pressure, which is written in bar. You might see something like PW 300, which just means it's pressurized to 300 bar. You absolutely need these 2 numbers before you can do anything else. Moving on to step 1, total volume. Let's find the sheer volume of breathable air physically compressed inside that tank. The math here is a super straightforward mental shortcut. Step 1, note your water capacity. Step 2, note your working pressure. And step 3, just multiply that capacity by the pressure. This gives you what we call the total volume, or TV. This number represents the nominal amount of breathable air available to you, basically your raw starting point. Let's look at 2 standard cylinder sizes to put this into perspective. For a 6.8-liter cylinder, if we multiply that by 300 bar, we get a total volume of 2,040 liters. For a larger 10-liter cylinder at 300 bar, you're carrying 3,000 liters of air. Think about that for a second. That is a massive amount of air compressed into a really tiny space. So we know how much air we have. Let's move right along to step 2, total duration. This is where we bring actual human biology into the equation. We need to figure out how fast that air will be consumed. You see, air consumption isn't just a static number. It's directly tied to how hard you're working. To find out how long your air will last, we have to look at your respiratory minute volume. Simply put, that's the amount of air moving in and out of your lungs in 1 single minute. Think about the sheer contrast here. A resting adult, someone just chilling in a chair, uses only about 5 to 8 liters of air a minute. But let's be real, nobody wearing an SCBA is resting in a chair. You are working, you're moving, you're sweating, you're carrying heavy gear. During moderate exercise, your breathing rate absolutely skyrockets to somewhere between 40 and 60 liters a minute. We have to account for that heavy physical exertion. Because of that intense physical demand, SCBA duration calculations use a standardized guide. And that magic number, it's 40 liters per minute, or 40 LPM. This is the golden constant used across the board. So whenever you're trying to figure out how fast you're eating through your air supply, 40 LPM is the rate you always use. So the crucial point here is applying this 40 liter per minute constant to our formula. To find our total duration, we take the total volume and divide it by our 40 liter per minute breathing rate. Let's look at our 6.8 liter cylinder with 2,040 liters of air. Divide that by 40 and we get 51 minutes. Simple enough, right? For the 10-liter cylinder, 3,000 divided by 40 gives us 75 minutes. But hold on a second. This calculation implies going from a completely full cylinder to a completely empty one, and in a hazardous environment, breathing your tank down to literal 0 is a deadly mistake. That brings us to our most vital calculation, step 3, working duration. We absolutely must introduce a safety factor into our math here. Thankfully, most SCBA equipment features a built-in safety mechanism, which is the warning whistle. This whistle activates when you have about 50 to 55 bar of pressure left in your tank. It's a loud, completely unignorable alarm telling you, hey, your air supply is about to give out. Because of this, a strict safety factor has to be applied to your primary SCBA gear. So here is how we break down the formula to find your actual safe working duration. First, calculate the safety factor itself. Take your water capacity, multiply it by the whistle bar, and we'll use 50 bar for our math today, and then divide that by our 40 LPM constant. Once you have that safety factor time in minutes, step 2 is to subtract it from the total duration we figured out just a minute ago. Finally, step 3 is your result, your true safe working duration.
Let's run this for our 6.8-liter cylinder. The math for the safety factor goes like this: 6.8 times 50 bar divided by 40 LPM. That equals an 8.5-minute safety buffer. When we subtract that 8.5 minutes from our 51-minute total duration, we're left with a working duration of 42.5 minutes. So basically, your 51 minutes safely segments into 42.5 minutes of actual work time, leaving you an 8.5-minute buffer to evacuate when that whistle blows.
Now let's run that exact same calculation for the larger 10-liter cylinder. 10 liters times 50 bar divided by 40 LPM gives us a 12.5-minute safety factor. Subtract that from our 75-minute total duration and you have exactly 62.5 minutes of safe work time. But keep in mind, you might actually need to allow for an even larger safety factor depending on your specific mission parameters. Like, how long does it take to literally walk out of the hazard zone? You have to account for that. Before we move on, there is a very critical safety standard you must know. The AS 1715-2009 rule states that any cylinders with a working duration of less than 15 minutes are classified strictly for escape only. If your math results in a working duration under 15 minutes, that cylinder is absolutely not suitable for SCBA work. Period. End of story. All right, now we arrive at the ultimate test, calculating on the run. Because in the real world, you aren't sitting at a desk with a calculator before a mission, right? You are actively operating and your air is actively draining. You must be able to calculate this dynamically using your pressure gauge. Let's put you in a dynamic in-the-field scenario. You are in the middle of a hazardous SCBA mission. You're wearing a 10-liter cylinder. You check your pressure gauge and it indicates you have exactly 100 bar of pressure remaining. The critical question is, how many minutes of working duration do you have left before that warning whistle sounds? Okay, let's work this through mentally. Step 1, current total volume. That's your 10-liter cylinder times the 100 bar you see on the gauge. That's 1,000 liters of air remaining. Step 2, total duration. 1,000 liters divided by our constant 40 liters per minute. That gives us 25 minutes of total air. Step 3, the whistle's safety buffer. For a 10-liter tank, that's 10 times 50 bar divided by 40, which is a 12.5-minute safety factor. Finally, step 4, your 25 minutes of total duration minus your 12.5-minute safety factor. And there is your bottom line. You have exactly 12.5 minutes left of safe working time before that warning whistle starts blaring. By trusting the math, you can look down at a gauge that says 100 bar and instantly know exactly how much time you have to finish the job and get out safely. No guessing required. This explainer wasn't just about crunching numbers for fun. It's about giving you the practical tools to command your equipment and totally own your safety. The math is simple, but the stakes are absolute. By knowing your total volume, applying the 40-liter per minute standard, and always calculating for the whistle safety factor, you take the guesswork out of survival. So, I'll leave you with this final thought. Are you ready to trust the math on your next mission? Keep these formulas sharp, stay safe out there, and thanks for joining me for this explainer.